Hello, this is Bruce Hubbard, and this is the continuation of Arduino variables. And what we're going to do is we're going to modify our previous Blink program so that it uses variables. First thing we're going to do, however, is add a additional line of comment here. Bruce Hubbard, 2 B's. It's going to be version 1.1, and it's going to be 2014-09-12. And we will also go up here to File and do a Save As, and save it. Make sure that it is going to our Arduino's folder, and it is. And I'm going to save it as myblink underscore BLINK underscore 2. Yeah, I know it's version 1.1, but I already called one of them 1, so myblink 2 sort of keeps track of it all. Okay, so what about variables? Variables over here, you can see, have different properties. They've got names, they've got something called scope, and they've got something called type. And both of these are important. So let's start for variable names, which are easier. Variable names start with alphabetic letters. They can have any number of following letters or numbers. You can put an underscore in the name, but no spaces. Capitalization counts, and the name loop and the name capital L loop are not the same. It is common to run words together to explain what the variable stands for. And it is common to start with a lowercase letter and then capitalize each successive word. So over here we have examples. Small l, ed, pin, capital P-I-N. That's our LED pin name. Here's another one. LED, capital P-I-N, number 1. There could be an LED pin number 2. L's and 1's sometimes run together and you can't tell the difference, and so some people like to go LED pin underscore 1 so that the numbers stand out a bit. We could have a red LED pin. We could have a delay time, and so on. This incidentally is called camel case. It starts low and then it has a hump. Each additional word is capitalized, so on. Okay, now we've got some examples of non-legal variable names. One wish starts with a number. 2 plus 2, pluses aren't allowed in variable names. Abra space cadabra, no spaces. Underscores are okay in the middle of a variable or connecting two pieces of it. Use those if you really want a space. Leading underscores is not a good place. Underscores before and after are not a good place, and underscores at the end are not a good place. System code uses underscores in those places, and you run the risk of really strange bugs if you get into creating variables with those sorts of names. Okay, next, variables have a type, which tells the computer how much memory to reserve for it. Memory comes in bytes, 1, 2, 3, 4, 5, 6, 7, 8 bytes, etc. What sort of data to expect in it? Numbers, alphabetic letters, strings of characters, things with decimal points in them, more complicated kinds of data. There are also many different data types, but there are some common ones that you will see fairly often. One is the int, short for integer, and these are whole numbers like 1 and 13. The next one is the float. This is short for floating point. That means it has a decimal point, like 1.1 or 1.3. You get more accurate calculations than with an integer, but it's slower and more space consuming. Char is for characters like single quote A, single quote. We'll talk about those later in the class. And Boolean are logical variables, and these can only have 2 values. They can be true or false. Okay, we're getting close. Variables are created or declared by following this template. The type name followed by the variable name, and the type name followed by an equal sign and initial value, both of them end with a semicolon. Okay, examples. Int, red LED pin, equals 13. Int is the type. Red LED pin is a made-up name for a variable. And equals 13 says that once the computer has acquired the memory for it, put the number 13 in it. We can say int, no initial value here, semicolon. It's got nothing in it, and you would be in trouble if you used it without putting something in it. Here's a float. I have a short version of pi called mypi, 3.14. Found a bug, 3.14.529. No 2 decimal points in floating point numbers. And then there's float, and there's the real pi, which is a defined constant, capital P, capital I. It exists on all C systems. And finally, Boolean variable, lights out, can be true or false potentially, and it starts out equal to initial value of true, semicolon. Okay, yeah, we'll finish with the lecture. Next we come to scope. Scope refers to where a variable can be accessed, and that would be fancier language rather than where it's available. And variables declared at the top of the program or outside of any function, we'll talk about that later, are global in scope and can be accessed from anywhere. Variables can only be accessed after they've been declared. This means running down the paper. Once can't use it before you say int or float. Afterwards, everything's good. This is also called lexical scope and refers to the textual location on the page. Okay. So let's go over here to our program, stick in a space or two, and we're going to want 2 variables really here. We want to get all the numbers out of this program. So our first problem is we've got the pin 13. We want to get rid of the pin 13 because we want to change it to 10 or 12 or 3, and we don't want to go all over our program changing it. It's a small number. It has no decimal point in it, and so it looks like a good candidate for an int. We're going to make it a global. And we're going to start out, and we're going to say that our global declarations are at the top of the program, and they are outside of anything like a void setup or a void loop. They're just out here in free space. Okay? Int, that's the type. All right, we can call the variable anything we want. We could call it LED. We could call it pin. I sort of like LED, capital P-I-N, and it currently has a value, and that value is 13. So I'm going to say space equals space 13 semicolon. It's a valid declaration. You can go up here and test it with the little check mark command, and it says it's compiling the sketch. And if we wait for a little bit, it's done compiling, no complaints. All right. We declared it, we didn't use it. Some versions of C will complain if you do that, the really picky ones. This is not a really picky version of C, and it lets you get away with a lot of stuff. Okay, we also want our, let's go ahead and use it, all right? So I'm going to make my life easy. I'm going to double click on it. I'm going to Command C, copy it. I'm going to go down here and double click on all my 13s. That's one way to do it. I could go through and replace them all, okay? But I'm only using 13 in one place. And so what I'm going to do is Command F for find, and I'm going to find the number 13, comma, which is all the 13s that are being used in argument lists. See, they're all 13 commas. And I'm going to say replace it with Command V, paste LED pin, comma, don't want to lose the comma, and I am going to replace all. I could also do a find. See, found the first one, and I could do a replace, LED pin, and I could find the next one, or, because I've been very careful about my 13 commas and my LED pin commas, I could replace all, and in one fell swoop, I've taken care of all the 13s. They're all called LED pin, That's kind of nice. Digital write LED pin high, delay for a while. Digital write LED pin low, delay for another while. All right, we know what we're writing to. Let's see if we're still good. Test compile. Compiling sketch, done compiling, no red complaints. Okay, let's add another variable. What other numbers are we using? We're using 100, and we're using 1,000, and we're using 500. So what can we do here? Well, make some more variables. Int, and I'll call it delay, and it turns red. That means I can't use it as a variable because it's in use somewhere else in the program. In fact, as the function that delays things. But I could say, let's make something up, delay short, and delay short, it's not red any longer, so I get to use it, equals, what's my small number? 100 milliseconds. And I'll make another one, int, delay, medium, equals, what's my next number? 500, in between the two, 500 milliseconds, and int, delay, long, capital L, this is camel case, concatenating my words, delay long equals 1,000 milliseconds, which is the amount of time. Now we could put some comments on these if we wanted to. And we could say that's our test LED on pin 13. And we could say that over one, line them up nicely, that these are various blink, INK delays. Don't want to get too much into this, okay? And in fact, down here, there's a whole bunch of turn LED on, turn LED off. That gets to be kind of a really monotonous comment on the end of that line every time you cut and paste it, and it doesn't really tell you anything useful. It won't take you long to know that digital write to an LED pin high means turn it on. Okay, but what are we going to do here? Delay short, copy. Let's look for our hundreds. We can't do a global replace this time because, well, we could do the 1,000, but there's just not enough hundreds and thousands to make it worthwhile. So that's our delay short. 1,000 is our delay long. Copy, Command C, double click here, paste, double click here, paste, and then we've got a 500 here. We go up and find our 500, copy, double click, Command V, paste. Okay, let's give it a test compile, see if it works. Yep. Okay, we have now gone and made 4 global declarations. They're available everywhere inside the program. We're using them inside loop because they're global, they're visible from inside loop, and we are digital writing every time to an LED pin. It could be any pin at all, but we've said it's 13 currently. And based on our program, we have a short, a long, and a medium delay. So instead of a line-by-line comment, I could have like a, whoops, yeah, let's start out loop with blink, LED, several, SEVERAL times. That's the whole program. Inside it, let's add some comments for each individual block of code. And this is going to be the short blink. And we'll go and add one additional line here, put another block comment, and we're going to call this the medium blink. Okay, great. It's not over-commented. We've said what we're doing up here. Oh, no, we haven't. Bruce Hubbard, version 1.1, what did he do? I have added global variables. And it's a little late. Horse is kind of out of the barn, but I'm going to go back to version 1.0, and I'm going to say it should be stored in file _0, but I never seem to do that. I always start out with version 1. But version 1.0 was initial, INITIAL, initial version, using numeric constants. Okay, let's save it, Command S. And now we can plug in our Arduino and we can run it. And I have an Arduino handy here. There isn't a webcam yet to look at it, but I will plug it in. There it goes. I will go up to Tools. Under Tools, I will look at the board. The board is an Uno. I will look at my port number. My port is the TTY USB modem. That is correct. Get out of that little menu. Clean up the screen here. And let's use the sideways arrow, which is the upload arrow. It's compiling, it's uploading, and it's done uploading. And you can't see it, but over on my left-hand side here, I've got an LED doing short and medium blinks. Thank you very much. Well, here as promised is the Arduino blinking its heart out with its little red LED. You can see the red LED over here. It has a short blink, a medium blink, and over here is an RGB LED plugged into the board, which you're not supposed to do, so you didn't actually see that.